Okay, so we're gonna look at a few more practice problems. I'm gonna start with this one. So this similarity is often applied to being able to find lengths of things using the idea of shadows and the sun. And this is how like kind of ancient times, the Egyptians and stuff measured things. We don't use it anymore because we have much more advanced technology, but it is a way to apply similarity to like real life concepts. So it says Mr. Childress decided that he wanted to know the height of the Statue of Liberty. He placed a mirror on the ground 152.5 feet from the base of the statue. He then walked backwards until he could see only the very top of the monument in the mirror. He was 3 feet from the mirror at that point. Using similar triangles, how tall is the Statue of Liberty? Okay, so what we can do, they told us these triangles are similar, and so we can set up, it's called a proportion, and then solve that proportion to find x. So what I do is I use the triangle that I know. I know the height is 6 and the base is 3. And I'm going to set that equal to the ratio of this triangle. That's a proportion. A proportion is just a fraction equal to a fraction. So this height goes with the height of the Statue of Liberty, which is x. And the distance between the mirror and Mr. Childress and the distance between the Statue of Liberty and the mirror are what we compare. So we would do 152.5 would go with the 3 because they're both on the ground. And then when you solve this, you cross multiply. So when you cross multiply, you multiply 3 times x and then 6 times 152.5, and you put the equal sign in the middle. Okay, so 6 times 152.5 gives us 915. And then if you divide by 3, you get 305. And so the Statue of Liberty is 305 feet, probably approximately based on this. So that's one application. Okay, another one is, and there's like homework problems like this, is in the following figure, name the similar triangles and how you know they are similar, then find the missing parts. Okay, you cannot find x and y until you take that the triangles are similar, and you only determine the triangles are similar based on this given information. So they said BC is parallel to DE. They told me AB is 4, DB is 12, AC is 5, CE is X, BC is 8, and DE is Y. Okay. Now, I don't really need any of that information because they told me these lines are parallel. And if I know those lines are parallel, I know this angle ABC and angle BDE are equal. Okay, or congruent because they're corresponding. And we know that BC is parallel to DE. And so again, it's like we have these two parallel lines and we have this angle and this angle. They're both on the top right of the line. And so those are corresponding. Okay, we have another pair of corresponding. We have angle ACB and CED. And it's the same reason, corresponding angles are congruent. I guess since I should more instead of and I should say since BC is parallel to DE. Great, and that's enough. I have two pairs, so these are similar by angle. But you could also say that angle A here is equal because again, what we're doing is we're comparing this triangle ABC, which is this 4, this is 5, to this other triangle ADE, okay, and this is 8. And we know that again, this angle is equal to this one. Angle C here is equal to this angle E. And then these angle A's are a shared angle, so they're equal, like angle A is congruent to angle A. Because they're the same angle. So you could also use that angle. Again, you only need 2, but you can have all 3. Okay. So we prove the triangles are similar, angle, angle. I'm going to write the similarity statement. So BAC is similar to triangle, and I'm just going to match up the angles. So it'd be DAE. Okay, and again, it's by this angle. Now, once we know that, we can now find our X and Y. So we know that this side is 4 plus 12, which is 16. This side is going to be 5 plus X, because to get this side, we would put these two together by adding them. So that's 5 plus X. Don't make it 5X because it's not 5 times X. And this is Y. And then we set up our proportion again. You have to set up two sides that you know that don't have a variable. So I know that this 4 goes with 16. So I have to use that. And then I'm going to do like 8 with Y. Again, I'm using the small triangle on top, the large one on bottom. And then I'm going to cross multiply. Okay, so that's 90. Sorry, my computer was freezing a little bit. That's 96. Okay, then Y is equal to 24 because I divide by 4. And then to get X, we're going to do the same thing. You still use the 4 over 16 because those are two sides, corresponding sides that we know. And then we would be 5 over 5 plus X. Okay, so when we cross multiply, we would get 4 times the quantity 5 plus X, and then 16 times 5. For this, you have to distribute. So you get 20 plus 4X equals 80. And then you would subtract 20. So you get 4X equals 60. And you would divide by 4 and you get X equals 15. So the key thing again is first prove the triangles are similar, generally not using the sides, and then find the missing side. Okay, and so that should help with one of the homework problems. If you have any questions, let me know.